Hi, everyone. Thanks for joining me today. My name is Anthony Shimana, and I'm a senior consultant at Industrial Logic. Today I'm going to be working through the Parrot Kata. If you'd like to follow along, you can clone the repo. The link to the repo will be in the description of the YouTube video. Now, if you're not familiar with the Parrot Kata, it's from a code sample from this book, Martin Fowler's Refactoring book. Now, this is the first edition. All the examples in this book are in Java. In the second edition that just came out in the last couple years, it has a black cover, and all of the examples in the newer edition are in JavaScript. So whether you get the first edition or the second edition, I highly recommend it. There are some other small differences between the two, but I couldn't recommend this book more. It's probably in my top 5 programming books, and all of the refactorings that we're going to be doing today are described in this book. So let's jump in and take a look at the Parrot Kata. So the Parrot Kata is inspired by Monty Python, and what made me think of this is I recently introduced my son to Monty Python's Flying Circus and reminded me of this kata. So I figured it'd be a great opportunity to go through this refactoring kata on my blog, and if you all like it, please reach out and let me know, and I'll be happy to make more of these videos. So the purpose of this kata is to introduce the switch statement code smell and to provide people an opportunity to practice refactoring to eliminate that code smell. So when we're looking for the switch statement smell, we're going to be looking at this GetSpeed method. And when I'm looking through production code that I'm maintaining for the smell, I'm really looking for 2 things. So the first thing that I would look for is switching on type. So if we look at line 18 here, we see that we're switching on type. That type is this parrot type enum that's being passed into the constructor. So that's one indicator, right? That we're switching here on a European case, an African case, and a Norwegian blue. The second thing that I would be looking for is if we're doing the switch statement in multiple places. So it might be in several different methods in this parrot class, or it's very common to have the switch statement kind of strewn throughout your code base. And if you see that, that's a really good indicator of the switch statement code smell, and that you'll make your code easier to understand, easier to update and modify without creating bugs if you do refactor away from the switch statement and into a polymorphic solution. Now, this kata, since it is simple, right? The idea of these katas is that you can practice them over and over again, and they're simple things that you can practice, and you can kind of get the benefit of repetition. This kata only has the one switch statement in it. So if this was production code that I was looking at, I probably wouldn't refactor this code yet if I only found one instance of that switch statement. And you'll see that's because in our the solution that we end up with after we refactor the code, there still will be a switch statement. But that switch statement is going to be buried in a creation method or a factory method where we're switching on type to create the concrete instances of Parrot. But then everywhere else, we won't be switching on type, and we'll just be we'll be dealing with the parrots. Okay, let's take a look at the tests. We do have tests. There's 7 tests here. Let's run them. It's important to make sure that we're always starting our refactoring with a set of passing tests. And we see all 7 tests pass. So where I would likely start is with the first of 2 refactorings. And again, they're both described in the refactoring book. The first step is to set up the infrastructure, and that refactoring is called replace type code with subclasses. So that's the infrastructure that's going to create our subclasses for us. And then once we have those subclasses in place, the second refactoring that we're going to do is called replace conditional with polymorphism. So I kind of will think about us doing kind of 2 legs of the refactoring together, and we'll do them in those 2 separate steps. So if we think about the goal of that first step, it's to get to those different subclasses. In order to do that, we're going to want to stop creating parrot objects, right, and create these concrete objects instead. So what I want to do is I want to kind of put a middleman in between the creation of the parrot and any of the clients of the parrot object, which for this kata is just the tests. So what I want to do is introduce a creation method. So I'm going to say, we'll make it a static method that returns a parrot, and we'll call it create. And now what I'm going to do is I'm just going to copy all 4 of the parameters to the parrot constructor, and I am just going to paste them into our creation method. Here we'll just return a new parrot. Okay, now we'll go to our test, and now we're going to want every place in our test that is creating an instance of a parrot directly, we want it to call through call through our creation method. So we can rely on IntelliJ for that. So we can do a find here, and we'll find all the places we're calling the constructor directly, and I can do a replacement with the creation method in our scope. We want to just be in our current file. I'm going to say replace all, and we see there's 7 occurrences here, and I know we have 7 tests, so that works out. So we'll go ahead and do the refactoring. We can see now we're calling our creation method, and we can rerun our tests. Great, all tests pass. So now let's get back to our parrot class. So the next thing that I want to do is when we end this refactoring, I want to get type out of the parrot class, and I just want the subclasses supplying their type. So what I want to do next is I want to make type a self-encapsulated field, and that's just really a fancy term for creating a getter for type. So from here, we can do a and bring up the refactoring menu, and down here at the bottom there's encapsulate fields, and I just want the parrot type enum that I want to encapsulate. So I'm going to say refactor, and now if we look at line 22, you can see we're calling get type. I'm just going to move this up closer to where we use it for the first time. And again, that should all, we can run our test, that should pass. We're just introducing a getter. And we see all 7 of our tests pass. Okay, so now what I'm going to do, this next step, we're going to create our subclasses. And again, this will be in 2 steps. The first step is going to be to create the subclass and override the getType method. And then the second step is going to be to create the instance of the new subclass in the creation method. So those are our 2 steps, and we'll do that for each of these new subclasses we create. So we can start here by saying let's create a subclass of parrot. The first one is going to be called a European parrot. And it's asking if we want to save it if we want to add it to Git, and we won't, since this is just a demo. Let me zoom in here. Okay, so for here we're going to say override get type, and I'm going to return the European type. Now we'll go back to our parrot class. And here I'm going to say if type equals European, we're just going to return a new European parrot, passing down those same parameters that we passed into the create method. Okay. Now let's run our tests. Great. And we still have all 7 passing. So let's take a look at what we did here. So we created this European type, and we are now creating that in our creation method. So when GetSpeed gets called on the European parrot, we're calling getType, which is now calling the overrided method that is just returning a hard-coded European case. And then we're calling through to this getBaseSpeed. So we made a very tiny change, but it was behavior preserving. So that's like the habit that we want to get into when we're refactoring is we want to make these very small changes that preserve behavior that gets us to our next change, and being able to make these very small changes so we can run our tests in between. So as soon as we make a mistake or make a change that changes the behavior, we can undo and get back to a working state, right? We can make a graceful retreat and get back to a working state very, very quickly. Okay, so we're going to continue that same pattern for the next two parrot types. So now we're going to create another parrot subclass, and this is going to be called an African parrot. So we'll override type, return the African type parrot, and then we'll add that condition to our creation method here. Rerun our tests. Now I could make this a switch statement. Because we only have 3 cases here, I'm not concerned about that. I'm okay with these still just being if statements for now. So let's go and make our third one. Now this is probably getting pretty boring, so just bear with me here for a moment, and we'll be on to our next step. So this is going to be our Norwegian blue parrot. Okay. Now our last case, say we have a Norwegian blue. We'll just create an instance of the Norwegian blue parrot. And run our tests. Okay, so we are getting close to being done this first leg of the refactoring. So now we have our creation method in place. So the next thing that I want to do is I want this type to be supplied by the derived classes only, right? The child classes. So I would like to make this abstract and get rid of the type out of I want to get the type field out of the parrot class. I want to make this abstract, I need to make the parrot class abstract. And to make the parrot class abstract, well then we can't be creating an instance of it here. So when I'm refactoring, I'm thinking, what's the next small step I can make that enables the step after that? And that's kind of, you'll get in the habit of thinking in those terms the more you do these types of refactorings. So right now, this is dead code. We only have 3 types of parrots, so we can't ever get to this state. So I'm just going to, instead of returning a new parrot, I'm just going to say, let's throw a new exception here. We can make it an argument exception. And we'll just say unknown parrot type supplied. Now this is more of like a programmer protection, right? The way this would trigger is if we added a new parrot type. We call create method with it, but then we never updated this code, right? So I'm okay with just adding this exception here in place of the creating the new parrot, since that was unreachable code. So let's go ahead and run our test. This shouldn't change anything because that's not really a case that we support. And all 7 of our tests passed now. Okay, so now that we are no longer creating an instance of a parrot object, we should be able to make this abstract. Now that this is abstract, we can come down here to get type and we can make this abstract now. And run our tests. Great, all 7 passed. So now let's scroll back up here, and now we can see that the type is no longer being used. So now we can begin to remove that. So we can just say remove field type. And now we can see how that affects our other classes. So the parrot type enum that we're passing into the constructor can also be removed. So let's safe delete that. And now we will want to go to the subclasses, right? Because before we were just mimicking the constructor parameters to the parrot in our child classes. So let's go to each of those and clean those up. So we can start with the European parrot. We can save delete type here. Let's go to the African parrot, do the same. And the Norwegian blue, do the same. And let's run our tests. And they all pass. Now, I could have run the tests in between each of those removals, but the ID was showing me that it wasn't used and it could save deleted, so I felt like that was a save change. So again, we're just trying to run our tests regularly. Sometimes you might make a couple steps before running your tests, but you want to always be in the habit of rerunning those steps, rerunning those tests. Okay, so I think at this point we are done that first leg of the refactoring. So at this point now we're going to start on the replace conditional with polymorphism. So for that case, what we're going to do is we're going to start wanting to implement GetSpeed in our child classes. So the first thing that I want to do is we'll take each one of these types in order. Let's look at the European type. And for this one, we're just calling getBaseSpeed. And here I want to figure out what can I push down to the child classes and what has to stay in the parent class. So if we look at getBaseSpeed, we see that it's also being used here in the African case. And then also, if we look at this getBaseSpeed that's used by Norwegian Blue, it's also calling it. So this is something that we're going to need to keep in the parent parent class. So what we do know though is we're going to need to call it from those child classes. So the access modifier for getBaseSpeed is incorrect. So we're going to have to make this protected. Okay, so once that's protected, the next thing I'm going to do is I'm just going to copy this line out of the European case. I'll go to my European parrot and say override GetSpeed and just paste that line in. We can run our tests. And they all pass. Now we can go back to our parrot and we can delete this case and rerun our tests. Great. Now at this point, we're going to follow that same pattern for the African parrot case and the Norwegian blue parrot case, but each one of these is going to get a little bit harder. So now if we look at the African case, it's doing its calculation based on calling getBaseSpeed that we already talked about, and that's going to stay in this parrot class. But it's also calling this getLoadFactor method and using the number of coconuts field, and those are only used by the African parrot. So there's a couple of things that we can do here. We're going to want to get both of these into that, push down into that African child class. And so there's a couple of things that we can do. One way we could do it is we could actually copy getLoadFactor and number of coconuts into the child class and then come back and delete them here. Now, another option is we can lean on the IDE to push these down, and we will be in an uncompilable state for a short period of time. Now, I'm actually going to just lean on the IDE to do it. That way it's less manual work. We can showcase some additional features of the IDE, and I don't believe we're going to be in a non-compiling state for very long. So we'll go ahead and do that. Now, IntelliJ will let us push down both of these at the same time, or we can do them individually. Since I'm relying on IntelliJ to do it for me, I'm going to push them both down at the same time. If I was doing this manually, I would do them one at a time. So let's get started there. So there's the getLoadFactor private method and the number of coconuts field. Both of those have to get pushed down. So we can start here, bring up our refactoring menu and say push members down. So getLoadFactor should be selected since that's where we started the refactoring from, and then number of coconuts as well. Now, if I just said refactor here, it's going to try to push them down to all three of our subclasses because that's our current structure. Now, because we know that we only want these, we're only targeting the African parrot class for this, I'm going to want to do a preview. Now, the first thing it does is it shows us that some problems are detected. It tells us that we're using get load factor and the number of coconuts field and get speed. Well, we know that, right? That's the logic that we want to push down into the child class, so that's okay. And then it tells us that there's a problem with the constructor. So it's telling us that we're going to be in an uncompiling state, and we're okay with that. We know that we're going to need to fix that. So we'll just continue here. And here we get our refactoring preview menu. So this is where we're going to decide what object we should, or what class we should push these, the field and the method down to. So we want it to go to the African parrot class, but we want to exclude the European parrot. So I'm going to say exclude here, and Norwegian blue we're going to exclude here. And then I'm going to say do refactor. Now you can see we have some red here. But what I'm going to do is I'm going to copy this line like we did before for the European type. And I'm going to go to the African parrot class. And I'm going to say override GetSpeed. And I'm just going to paste our code here. Now we can see we have an issue with this number of coconuts. But what we can do here is I can say bind constructor parameters to fields, and we want to bind number of coconuts. I'm just going to say OK, and now this class is good. Now let's go back to the parrot class, and here we see we don't need number of coconuts anymore, and we can delete this case. So let's go ahead and run our tests now. And all 7 tests pass. You can see we weren't in a non-compiling state for very long. You can see that there's some more cleanup that we can do, but we didn't do that in a red state, right? We want to get out of that red state as quickly as possible. So we got back to green, got all of our tests passing, and now we can go in and do a little more cleanup before we go on to this last case. So the cleanup I want to do here is now that we remove the number of coconuts field from parrot, let's get rid of it from the constructor, and then we'll go ahead and trace that back to the child classes as well. So let's say safe delete number of coconuts. Right, we can run our tests. And now let's go through them. European parrot no longer needs number of coconuts in its constructor, so we can safe delete that. Run our tests again. Now African parrot, we know we just pushed that down, so African parrot should be in a good state. And now Norwegian parrot no longer needs, or Norwegian blue, I should say, no longer needs the number of coconuts. So we can save delete there and run our tests. Great. So now let's go back to our parrot class, and now we can do our last type here, which is Norwegian blue. Now again, this time there's 2 fields that can get pushed down. Is nailed and voltage are only being used by the Norwegian blue type, and then this get base speed that takes a parameter. The kind of overloaded get base speed that takes this voltage. The get base speed that doesn't have any parameters we already dealt with, and that needs to stay here. So we can move all 3 of those down into the Norwegian blue class. So we'll do the same thing that we did last time. We can just pick one of them. We can say get base speed and bring up our refactoring menu and say push members down. So push down get base speed, voltage, and is nailed. And again, we're going to preview because we don't want them getting pushed down to all 3 of the subclasses. Yes, we know there's some problems. We'll continue. And now we're going to say we want to exclude the African parrot case and the European parrot case we want to exclude, and we want these to go to Norwegian blue. So we'll do the refactoring. I'm going to copy this line again. So copy the get speed functionality for the Norwegian blue case again like we did previously. Go to our Norwegian blue class and say override get speed and paste. Okay, and now we can bind these variables again, so we can say voltage. We'll bind voltage. We'll do the same for is nailed. go back to Parrot, and again, we can delete the constructor, delete the functionality in the constructor, and delete this entire Norwegian blue case, and run our tests. And again, we see more cleanup we can do, but we're not going to do it until we're in a green state. We see all 7 tests pass, so we're in a green bar state now. So now we can go about doing some more cleanup, and then we can come back and get rid of this GetSpeed method and make it abstract. But let's do some cleanup first. So we have this Parrot constructor that was taking 2 parameters, so we can go ahead and safe delete both of those. Now that we've safe deleted them, at this point we just have the default constructor, so we should be able to delete that, right? No reason having an explicit default constructor. Let's run our tests, find out. They all pass. Now let's take a look at our other constructors here for the subclasses. So here for the European Parrot, again, we voltage and is nailed that we don't need. So I could just delete this, but we're calling the European Parrot constructor. So that would create a compilation error. So what I'm going to do is I'm just going to safe delete each of these individually. Now at this point, we're only calling the default constructor. So let's run our tests, make sure that works, and then we should just be able to delete that now. Okay, all 7 pass, and now we'll delete this constructor, and we can run again. And all 7 pass. So now let's go to our African Parrot, and now our African Parrot, it also is taking voltage and is nailed, and doesn't need to anymore, so we can safe delete both of these. Rerun our tests. And we look at Norwegian blue, and Norwegian blue is looking good. Okay, so now let's come back to Parrot. Now my next step is I want GetSpeed to be abstract at this point. Now if we look at all that's left is our default case, which is our runtime exception, right? And this was the case is if we ever got to a type that we didn't recognize, right? So that kind of analogous to this runtime exception is our illegal argument exception that we have here. So I believe we can just delete all of this and make this abstract. Let's run our tests and see. I mean, this is it. We are at the end of our refactoring here. We have this get type method that's no longer being used. So if you remember in the first refactoring that we did, one of the first things we did after we created the creation method was to encapsulate the type field. So at this point, we're not using this at all anymore. So we can delete this, but then also delete all of the overrides in the subclasses. So we can say safe delete get type. We can say OK here. And now IntelliJ is going to tell us we have 3 overrides, and we can go ahead and clean those up too. So let's let IntelliJ do that and run our tests. All 7 pass. So at this point, I think we are pretty close to being done. There's just a little bit more cleanup that I would like to do. So if we come back and look at our African Parrot, we're calling super here, which is no longer necessary, so we could get rid of that. Run our tests. And in Norwegian blue, we're doing the same, calling the super constructor. Hang on. There we go. And run our tests. They all pass. And there's one last bit that I would like to clean up. And this is unrelated to the polymorphic solution, right? So that we are done with. But now that I'm looking at the Norwegian blue Parrot, there's something I don't like, and it's this get base speed method that takes the voltage. So voltage is being passed in here, but it's a field. So to me, that's a little messy. There's no need to pass voltage into a private method if voltage is a field. But the problem here is we were overloading the get base speed when this existed in the Parrot class. So if we just got rid of this, now we're going to be overriding the GetSpeed in the parent class. So if we highlight here, we can see overrides method in the Parrot class. So we don't want to do that. So instead, what I would suggest to fix this would be to rename this getBaseSpeed method. So if we look at how it's being used in getSpeed, we check if the parrot is nailed. If it is, we're returning a 0. Otherwise, we're calculating this base speed based on the voltage. Now, we could call it the non-nailed speed, or we could say calculate speed based on voltage, or just call it calculate speed and the parameters voltage. So I think out of all my options, at least for now, that's what I like the best. And it's okay to change our minds. Renaming methods is cheap, so we can always change our minds if we like something better later. So I'm going to rename this, and I'm going to call this, let's call this calculate speed. And we're passing it voltage, so I think that's good. And now what I can do here, now that we're passing, now that we've changed the name of this, we can remove voltage parameter. So I'm going to say change signature, and we're going to delete voltage from here, and I'll say refactor. Now, IntelliJ is going to say the parameter from voltage is used in the method body, but we know that voltage is a field, and that's what we want, so we'll continue. We'll see now it has picked up the field here. So let's run our tests. And everything still passes. So that's it. I believe I'm done. This is my solution to the Parrot Kata. So where we've ended up is we have a creation method that switches on type and creates our 3 different types of parrots. We can see the parrot class is very minimal. We just have an abstract getSpeed method and the one getBaseSpeed method, and now all of the specifics are in each of these child classes. So that's it. I hope you liked the video. If you are interested in trying out this refactoring, I did it today in Java. If you go and look at the repo, there's a lot of different projects for different languages there, so feel free to try it in any number of languages, and feel free to reach out to me. Take care.